So the exercise related to space physics. So the planet Mercury, as you can see, it orbits the sun. So a circular orbit is given. The main purpose of giving a circular orbit is to, for calculation point of view, it's slightly elliptical. The Mercury takes about 88 days to orbit the sun. So that's a duration, that's a time the Mercury takes. The average radius of the orbit is about 58 million kilometers. Calculate the orbital speed. So how to solve such question? If you need the orbital speed, the speed at which the planet is moving around the sun. So we'll use a formula. We have speed equals distance divided by time. So the orbital speed or a speed is distance divided by time. Whenever object move in a circular path, in one complete rotation or revolution, the distance travel is equals to 2 pi r. It's always because the distance travel is equals to the circumference, which is 2 pi r divided by t. So speed equals to, the pi is 3.14. And what about the radius? It is 58 million kilometer. So million means 10 power 6. So we'll write 58 into 10 power 6 divided by the time. It takes 88 days. So we have to convert these 88 days first into hours, then to minutes, and then to seconds. So it is in denominator. So it is 88 multiplied by 24 to get in hours, multiplied by 60 to get minutes, and multiplied by 60 again to get the total number of the seconds. How many seconds are there?
So, Mr. 760 million, it's 7603200.
Okay. So that is the total time it took. So when we simplify, what's the final answer for the speed of the Mercury? The final answer for the speed, the unit will be kilometer per second, like because the distance we took in kilometer and time we took in seconds. So how many kilometers it cover every second? .93. So it is about 47.9. Write your answer in three significant figure. So I write 47.93 is there, so 47.9 kilometer, or you can round off to 48 kilometer. Is it clear discussion?
Yes, sir, clear.
The next part, comets also orbit the sun. Name the force that cause a comet and the planets orbit the sun. What is the cause? What force caused the comets or the planet orbit the sun? What we call that force? So all the forces which are acting toward the center is called centripetal force. But here you should be specific. You should use the term gravitational force. So the gravitational force is causing the planets to move around the gravitational force is causing comets and planets to move or to orbit the sun. Add to a diagram, show the orbit of typical comet, like this diagram. This is a continuation of a question. This diagram, use its screen annotation, add orbit of the comet. You can use the screen annotation, add, keep one thing in mind, like you will make ellipse, that is one thing, and one side it should be, the sun should be nearer than the other. You have to show orbit, yeah, that's right. So this is correct. This also right, good. This also acceptable. So this is the orbit of the comet. And then next one, the speed of a comet changes during its orbit. On the orbit you have drawn, label up letter X, the position where the comet at its fastest speed. Like example, this is the orbit of the comet I drew. So this is the orbit of the comet I drew. Can you label the point X where the comet is traveling faster? What should be the position? Where should be X? Yeah, so this will be X, or here you can mention X. The point closer to the sun, because when it is closer to the sun, the potential energy is less, so kinetic energy is more. Or you can, this also X, you can label X here. The potential energy is less, so it will have greater kinetic energy, so it will move faster. Explain why the comet travels fastest at point X. It's of 2 marks. So what are the points you will include? You will mention that as the planet, the comet get closer to the sun, the potential energy get closer to the, first thing, the total energy is conserved. So when the comet get closer to the sun, the potential energy decrease, so kinetic energy increases, which result in increase of speed. That's why the speed of a comet increases. Yeah, that's also a good answer. Potential energy depends on the mass. The gravitational pull and a distance closer, so it's less potential. So kinetic higher as energy is conserved. That's why it will move faster. 1 mark when you mention the conservation of energy. 1 mark for a comparison between potential and kinetic energy. The next question. In 1969, astronauts left a reflector on the moon surface. The reflector consists of the mirror at 90 degrees to each other. Scientists on the Earth aim the light from a laser at a reflector and the light reflect back to them. The diagram shows 2 mirrors in the reflector. Complete a diagram to show the reflection. So how the light, like this is light from the ray of a light from Earth. When it hit one mirror, it undergo reflection. It hit the second mirror, it also undergo reflection. So we receive the same light back on Earth, what we send to the moon. The speed of a light in a vacuum is 300,000 kilometer per second. The average time for a ray of a light to travel to moon and back is 2.6. So in this case, what happened? So in this case, what happened, like example, say this is the Earth. and this one is the moon. We send the light from the earth, the light reflected from these reflector and bounce back. If I say the distance between the earth and the moon is d, so the total time the light take to travel and return back, the total time to go and return back is 2.6 seconds. So how much time it will take to only travel or go? If the total time to travel and return back is 2.6 seconds, so how much time it will only take to travel? That it will take 1.3 seconds. So time to move from the earth to the moon is half of it, that will be 1.3 seconds. And we have the formula, speed is distance divided by time. The speed is given 300,000 kilometers. Distance we don't know, and time you don't take 2.6. You will take 1.3. Why 1.3? Because 2.6 they mention that is the time for a ray of a light to travel to the moon and bounce back, like going and return back. But if that will be twice. So we just need the time to travel to the moon. That's why we take half of it, so 1.3. 1.3 is divided, other side will be multiplied. What's the answer in kilometer? 300,000 into 1.3. So it will be
230,769.
how much? Can you repeat? 300,000 times 1.3. Yes, so 390,000 kilometers. So 390,000, and because the speed, the unit of the speed was in kilometer per second, that's why this is 390,000 kilometer. Is it clear, this one? Then the scientists measure the time for a light to travel to the moon and back very accurate. And by the time is, but the time is different every day. Like it's not taking the same time to return back. Sometimes it's shorter, sometimes it is longer. Like some days it is shorter, some days it's longer. This is a graph. Like on 1st Feb, say here 10 boxes equals to 0.05. So each box is, so this will be 2. Because it's 4, 5, then 6, 7, 4, 6, 4, 7, 4, 8, 4, 9, 4, 5, 0. So this will be 2.55, 5, 6, 5, 7. So this was 2.57. So on 1st Feb, it was taking 2.56 seconds to return back the light. On 8th Feb, it was taking 2.47 seconds. On 15th Feb, it was taking about 2.63 seconds. On 22 Feb, it was taking about 2.69 seconds to bounce back. On 1st March, it was taking 2.52 seconds. So the time for the light to reflect back from the moon is continuously changing. It's not same. Like some days we have it's taking shorter time to bounce back. Some days it's taking longer time. What you can say about this pattern, like what you can conclude from this table, this chart, the graph? What conclusion we can draw from this? Yeah. Suggest what can be deduced about the orbit of the moon from the information in the graph. So what we can deduce, So first thing we can say that the orbit of the moon is not circular, because if the orbit of the moon was circular around the earth, yeah, it is increasing and decreasing, that's true. But why it is increasing and decreasing? Because the orbit is not circular. Because if the orbit was circular, so it should take for a light to reflect every day, it should take the same time if it was exactly circular. So what we conclude from this, that the orbit of the moon also, it's not a perfect circle, or it's not circular. Actually, it is slightly bent, or we can say elliptical. So when its orbit is elliptical, when it is closer to us, the light is reflected in a short time. When it is away from us, the light is taking longer time to bounce back. So this cycle shows that the orbit of the moon is not a circle, it is slightly elliptical. That is one point. The second thing is the cycle of the moon is taking about 27 days, 26.5 or 27 days. And this cycle is regularly changing. Like some places it is closer, some places away, then again closer and then away. So the points you will include, number one, the orbit of the moon is not circular or perfect circle. The second, the time changes with the cycle of 27 days. And the third point, 27, 28, you can mention. And then the third point, what will, that when it is closer, it take short time to reflect the light. And when it is further, it takes longer time to reflect the light. Is it clear what we can deduce about this from the graph?
Yes.
Okay. Then the last one, the scientists also discovered that the average time for the light to travel the average time, 27, you can also mention 27 days, is fine. The scientists also discovered that the average time for a light to travel to the moon and back is increasing every year. What further information does this give about the orbit of the moon? Like, say, we are in 2022, say it was taking 2.7 seconds on average, or 2.6 seconds on average. Then in 2023, it will take about 2.61 seconds. Then in 2024, it will take about 2.63 seconds. 2025, I'm just overestimating, like it will take about 2.65 seconds. So question is why the orbital time is increasing? So why the orbital time is increasing? It means the moon is moving away from us. And what might be the reason for that? The gravitational field strength of the earth might be decreasing. That's why the moon is moving away from us. Is it clear?
Yes, sir, clear.
Okay. Then another question. The diagram shows 4 planets P, Q, R, and S, which are orbiting a star. Yeah, as the moon getting away from us, the tide the tidal energy also decreases. Like the tides, the pattern of the tides also changes. The diagram shows four planets P, Q, R, and S which are orbiting the star. As you can see here, this combination of a planet and a star is most likely what we can say this. Use screen annotation to take the right answer. You can use screen annotation to take the right answer. What we call this combination. So this combination is a solar system. Because galaxy, like if it was a galaxy, then it should be a combination of many stars, solar systems. If it was a Milky, like that's our next topic, the Milky Way galaxy and the stars. That's our galaxy, and the universe is a combination, like collection of the galaxies will form a universe. Planet Q has a moon. On the diagram, draw the moon for planet Q. Use a screen annotation, draw the moon for planet Q. Draw the orbit of the moon for planet Q. Not moon, the orbit of the moon, sorry. When you're drawing orbit for, like, you should draw circular until unless they mention, like orbit of the comet should be, and add to a diagram the orbit of the comet. What will be the orbit of the comet? Moving around this central star. So that will be the orbit of the comet. And that's right. So on the diagram, draw the orbit of a comet. Planets near to the star take less time to orbit the star. So just why? Like, which planet will take shorter time to move around the star? S. So S will take a shorter time to move, and suggest a reason for that, because it will have low potential energy, greater kinetic energy, so it will move faster. Because closer, so potential is no, so kinetic will be high, or closer, it's more like covering a short distance. The planet P makes one complete orbit. During this time, yes, you can mention that also. The orbit is less eccentric, the orbital distance is shorter. You can mention that as an answer. Like the answer can be the star is like the orbit, the center of the orbit, like it's a orbital path you can compare. Smaller orbital path or a distance, or it is closer, and so large speed for a close planets. Or smaller orbital radius you can also mention. Now, planet P make one complete orbit, like this planet P. So this planet P, it make one complete orbit. Now, which statement is correct? If planet P move one time, this planet P started and then it returned back. Now, which statement is correct? C is correct. Planet S will make more orbit than P. Why? Because planet S is closer, so it will move, like it will cover more orbits than planet P. Then as a planet orbit the star, the distance between the planet changes. The planet P is 200 million kilometer, planet R is 50 kilometer. Calculate the maximum distance and the minimum distance between them. So P is 200, P is 200 million kilometer. And R is 50 million kilometer. The question is, what is the minimum and the maximum distance? The minimum distance, when they are on the same side, like if I hide the others, so minimum distance when R is here. And the distance of the R from this star is 50. And the distance of the P from the star is 200. So how much is the distance between P and R? What is this distance?
So Mr. 2 pi r.
No, not 2 pi R. The 2 pi R is a circumference. We need the distance between P and R only.
150 million.
150 million. Why? Because see, from P to the star, it was 200. From R to the star is 50. So how much is this distance?
So Mr. It's 200 minus 50.
200 minus 50, that's equal to 150. Yeah, 2 pi r is for orbital distance, and that is for one complete revolution. And then what is the maximum distance between them? How we can work out the maximum distance? So to get the maximum distance, R should be in the opposite side. Like R should be here. So this distance is 200 and this is 50. All the distances from center. So how much is this?
200 plus 50 equals 250 million.
Yeah, so 200 million plus 50 million gives 250. So that's how we work out the minimum and the maximum distance between them. So maximum was 250, minimum is 150. So these are some questions. These are some questions related to space physics. Next session, we'll do more questions from this exercise as well as the next topic, which is about the stellar evolution or stars, formation of the stars and the galaxy.